What's up, Honors Pre-Calc? So what we're going to talk about is we are going to be looking at solving radical equations. So there's a couple things. You want to eliminate the radical and you want to check for extraneous solutions. So you got to take what you got and you plug it in, okay? So let's just get right into it. The first one that I want to kind of talk about is it's in your packet. The square root of 3x minus 20 equals the square root of 24 minus x. So what you want to do, you want to square to get rid of that, right? You square that, you get 3x minus 20 equals 24 minus x. And it's just basic algebra. So add x, so you get 4x minus 20 equals 24. Add 20 to both sides, you get 44, and then you divide by 4, so x is 11. And then you take that and you plug it in. So if you plug it in, I'm going to do 33 minus 20. Is that equal to 20 square root of 24 minus 11? So 33 minus 20 is the square root of 13, and this is square root of 13. Yeah, we're good right there. That works. That's actually super great. All right. Let's take a look at another one. If you're going to look at another one, we're going to go ahead and um, let's look at a cube root one. Okay, so if we look at the cube root one, same kind of thing. Whoop, that's supposed to be. So you got the cube root of 2 minus 4a equals the cube root of 2a minus 1. So how do you get rid of a cube root? You cube both sides. So you're going to cube both sides. So if you cube it, you get 2 minus 4a equals 2a minus 1. And then it's just algebra 1. All right, so we're going to add 4a, so you get 2a equals 6a minus 1. Add 1, 3 equals 6a. A is 1/2. So what's important here is do you go back and you plug it in. So we'll go the cube root of 2 minus 4 times a half. Is it the same as the cube root of 2 times a half minus 1? Well, I believe this gets me 0, and this gets me 0. So 0 equals 0. It's good to go. So there's that one right there. Okay? So there's that one. There is another type. The other type is when you have a square root with a number or something else, right? So when you do that, let's look at one like the square root of 6y minus 17 equals 5. Okay, so you got one like that. So what are you going to do with that one? What are you going to do with that one? So the first thing you want to do is you want to square both sides. So if you square both sides, you get 6y minus 17 equals 25, right? And then you uh, add 17, right? You add 17 to both sides. So you get 6y equals 42. And then you divide by 6, so y equals 7. And again, it's important to plug this in. Is 42 minus 7 inside the square root the same as 5? Well, this gives me square root of 25, and that's 5. So then we're good. All right, let's look at another one. How about the square root of 18 minus 7x equals x? Same thing there. You square both sides. Now bring everything over because it's quadratic, right? And then we can x factor that. So what is that? What are factors of 17? What is it? 9 and actually factors of negative 18 that add up to 7. I think that's what? 9 and negative 2 or something like that? Yep. So then this is x plus 9, x minus 2 equals 0. So x equals negative 9 and x equals 2. But you got to go back and you got to plug these in. So if we plug it in, you got 18 minus 7 times negative 9. Is that equal to negative 9? So when you do this math, this gets the square root of 81. And the square root of 81 is 9. And 9 is not equal to negative 9. That's an extraneous solution. Check 2. Square root of 18 minus 14, is that equal to 2? Square root of 4 equals 2. Boom. We're good. So that's why you got to do that sometimes. Okay, so sometimes you have to do that. All right. Let's look at another type. The other type is when you have radicals and stuff. When you have radicals. So let me grab. So we're not going to do this one. I originally was going to do this one right here, but we're not going to do that one. Let's do. Um, you know what? We'll do two of them like this. So we'll do 6p minus 23 to the 1 half plus 7 equals 12. All right, so you're going to subtract 7. But then I'm going to do this. Look what I did here. This is the way you should do it. Put it in like that, and then 12 minus 7 is 5. And then you square both sides, and you get 6p minus 23 equals 25. Then you add 23 to both sides, you get 6p equals 48, and you divide by 6p, and so you get p equals 8. And then you test it. Okay, so 6 times 8 is 48. 48 minus 23 to the 1 half plus 7 is that 12. So 48 minus 3, or 48 minus 23 is 25. Square root of that is 5. 5 plus 7 is 12. 12 equals 12. We're good. All right. Let's look at a more insane one. Okay. If we look at a different one, I'll use a different color so we can keep track. If we look at this one, 5v minus 22 to the 2/3 power equals 4. So the first thing I'm going to do, I'm going to write this as the cube root of 5v minus 22, that is squared, equals 4, right? So how you undo something squared? You square root it. So we got 3v, the cube root of 3v, or 5v minus 22 equals plus and minus 2, right? So then you have two problems now. You got the cube root of 5v minus 22 equals 2, and 3v, cube root of 5v minus 22 equals 8, or negative 2. And then you cube both sides. So this is 5v minus 22 equals 8. 5v minus 22 equals negative 8. Add 22, 5v equals 30. So v is 6 over here. Add 22, so you get 5v equals 14. Divide by 5, v equals 14 over 5. And then you check them. You plug them in. Okay? And if you plug them in, both of these guys will work. So that's the extent of rational equations. I look forward to seeing you in class real soon, and may the force be with you.